All right, so last time we started section 1.6, we talked about the fact that in this section, the material is going to become things that look like quadratics, often anyway. And that makes it sort of nice in the way that we have tools to solve it. But we always have to check at the end to make sure that when we changed it into something that looked quadratic, we didn't get any solutions that are really not solutions to the original problem. And so we had done one example of that last time, and this is what happened. We had one, this x equal 5, that didn't actually work at the end. So we have to do that sort of extra careful step at the end to make sure that things do or don't work. Now on this one, we had one radical in the problem, and it was equal to something that didn't have a radical in it. On the next problem, we have two radicals, okay? So the process is still quite similar. It's just that we're going to have to replicate it a couple of times because we've got to get rid of both radicals. Now, how I wish that we could just square both sides and it would get rid of both radicals, but it doesn't work that way. The problem is that if I squared both sides, or if I squared the left-hand side, right, if I did that, I would have to FOIL it out and I'd still have a radical when I was done. So we're going to move one of the radicals. It's not going to eliminate the fact that we're going to have a radical when we're done, but it's going to eliminate the idea of having to multiply those two radicals together, which is quite messy. So the first thing that we're going to do is we're going to shift one of the radicals, and we might as well use the second one since it happens to be negative, to the other side of the equation. So I've got the square root of x and plus 4. Be careful that plus 4 doesn't start to look like it's underneath the radical. And we're going to do the same thing we did last time. We're going to square both sides. And that's very nice on the left-hand side because that's going to give me x plus 40, right? That's great. Excuse me. But when I square things on the right-hand side, that means I have to multiply them out. In other words, I have to multiply out square root of x plus 4 times the square root of x plus 4. That's what squaring does. It means to multiply it by itself. And that involves FOILing. So my first two terms eliminate the radical, at least for that part, right? Square root of x times the square root of x is x. The problem is that the inside terms and the outside terms don't. So when I multiply these two together, I get 4 square root of x. And when I multiply these two together, I get 4 square root of x. And that's 8 square root of x. And I've still got a square root of x. Does that make sense for everyone? Unfortunately, my radical's still there. I mean, it's going to go away eventually, just not in this step. And then my last two terms, the 4 times the 4 is going to be by 16. Now, there is something nice that you might see happening here. Do you see how I've got an x on the left and an x on the right? So if I subtract an x, that piece will go away. So that's actually a pretty friendly step. And then this 16 that I have on the right-hand side can move over with the 40 as well. So what's 40 minus 16? Real quick. 24. Yeah, 24. And then on the right-hand side now, I have the negative 8 square root x. We could square at this point if we want to. That would be okay. Not negative, sorry, it's a positive. So sorry. Yeah, it's a positive. We could square both sides if we wanted to. It would be okay. But it might be nice to divide the 8 before we square, just to keep the number smaller. So I have a 3 on the left, and I have a square root of x on the right. So what am I going to do now? Square. Yeah, now I can square both sides, and it will eliminate that radical that I have that's still hanging around. So the only possible solution now is x equal 9. That doesn't mean that it's really a solution. We do have to check. So even if there's just one, over here I had 2 solutions and I had to check them both, right? And one worked and one didn't. Well, I could have had 2 work, I could have had 2 not work. Over here I've only got one solution, but it could still not work. So we need to check it into the original equation that was given. So I have the square root of 9 plus 40 minus the square root of 9. And I want to know, does it equal 4? It's sort of a question, right? So the 9 plus the 40 is 49. What's the square root of 49? 7. And what about my square root of 9 here? That one's 3. Does that actually equal 4? Yes, it does. So my solution actually works. So that's good. I found a solution. It works. If I didn't, I'd just mark it out and I'd say there's no solution. But this one worked. So I actually have the solution of x equals 9. It checks. Any questions on that one? So when you have 2 square roots in the problem, you're going to end up squaring things twice somewhere along the way. All right? The next one doesn't have any square roots, but you might recognize that that power of 2/3 can be written in a radical form. Do you remember how we could rewrite the power of 2/3 so it looks like a radical instead? What is it? The cube root, good, of what was that, Melissa? X squared, right. So what happens, I believe that I've written this before, but if not, make sure that I've written it here now, is that when I have an m over n, this is the nth root of x to the m. All right, so the numerator is still attached as a power to x, but the denominator is becoming the radical part, the nth root. So this is equal to 1/2. Okay. So I really don't want a cube root, just like I didn't want the square roots over here. So I eliminated square roots by squaring. How do you suppose I'm going to eliminate a cube root? By cubing, yeah. So we're going to cube both sides. So that's going to leave us with everything that's under the radical. That's x squared. And then what is 1/2 cubed? Joe, is that you trying to tell me something? What do you think? 1/8's right. Good job. It is. 1 cubed is 1 and 2 cubed is 8. Very good. So what do you think is going to happen next? I need a square root because I've got an x squared, right? So square roots of numbers like 1/8 are not especially friendly because 8's not a perfect square, right? So it looks like this. Square root of 1 is fine. That's 1. But what is the square root of 8 if I try to simplify it?
2 square roots of 2?
Right, 2 square roots of 2. So we saw this back in chapter P. The way that this breaks down is to 4 times 2, right? And the square root of 4 is 2. So that's why the 2 is out in front, and that's why there's a 2 still underneath as well. There's one more problem with this. Anybody remember? I need to plug it in, but I'm not quite there yet. There's something before I plug it in.
Can't have a square root in the denominator?
Yeah, we don't have radicals in the denominator, right? And this one does. So what do? Well, it's actually not too bad. I just multiply by the radical 2 part. So on the top I have the radical 2. But on the bottom, these two pieces, what happens when I multiply the square root of 2 times the square root of 2?
It's 2.
It's 2. And then I have the 2 out here, so I will end up with a 4. So these two pieces are actually just the number 2. Multiplied by the 2 in front gives me a 4. And I cannot simplify the 4 with this 2 because the 2 here is under the radical and the 4 is not. So this is the final form of the answer before I go and I check the work, like Joe said. Okay, so we're going to check and make sure it works. Maybe I shouldn't box it in just yet. But that's our suspicion. Our suspicion is, at least our only option is, that this is the square root of 2 over 4. So we're going to go back to the original problem and check it out. All right. And I got a lot of things written on my screen. Let me delete this one. All right, so this is, and you know what? It is x to the 2/3, but I'm going to write it as the cube root of x squared just because it's easier to do the work for it, I think. So this is square root of 2 over 4 squared. And then I want to see if that is equal to 1/2, right? That's what I'm guessing or checking. Did you get all the pieces in there okay? Is it all right? Okay. All right, so when I square this, the square root of 2 squared is 2. And the denominator 4 squared is 16. So right now I have the cube root of 2 over 16. Let me move this down just a little bit. Okay, that wasn't what I wanted to do. Let me try one more time. There we All right. The 2 over the 16 will reduce. What is 2 over 16? Yeah, it's 1 over 8. And what's the cube root of 1/8? It's 1/2, right? Yeah, it is. So this works. So it did check out. It did actually end up working. And it works because it's equal to the other side, of course. And so this solution that we proposed was the solution, is in fact a solution to my problem. Okay, so those are some examples of what we deal with when we have roots. The next thing we're going to look at is absolute values. What do we do when we have absolute values to solve? So we saw back in chapter P what we did with absolute values, and they were linear equations. The difference right here is that this is an absolute value, yeah, but it's an absolute value of something that's quadratic. Did y'all see that? So that makes it somewhat different. I have something a little bit different going on. Now, the way that I start the problem out is still the same, okay, as when I did a linear. I set everything that's underneath or inside of the absolute values equal to either 1 or equal to -1. And the reason is because the absolute value of 1 is equal to 1, right? And the absolute value of -1 is equal to 1. So if either of these, 1 or -1, resides inside of the absolute value, and I take the absolute value, I get 1 out of it. That's where that's coming from. Now I've got a quadratic, just like what happened with my roots. And I use what I know about quadratics to solve. Now it's a quadratic that's actually quite nice because it doesn't have a linear term, right? I don't have to factor this to do it. It's possible to do this differently. In particular, I can actually isolate the squared term and square root. So right now I have a squared is equal to 2. And what would I do to solve? Yeah, I'd square root. So what are the potential value or values that a is equal to here? What's that? Positive or negative. I'm going to get both of them with the square root of 2. So I have 2 possible answers from that. Let's do the other one. On the other one, it's kind of interesting because what happens when I add 1 here? Yeah, I get 0. And if I take the square root, do you know what the square root of 0 is?
0.
It's 0. So I only get 1 possible solution out of that. So I have 3 different solutions to check inside of my equation, right? Positive square root of 2, negative square root of 2, and 0. So let's check each of those. So we're going to check a equals the square root of 2. And then we'll check a equals negative square root of 2. And then we'll check a equal to 0. So on the first one, I'm going to do an absolute value of the square root of 2 squared minus 1. And I want to know, does that equal 1? So if I do square root of 2 and I square it, I get 2 minus 1 is 1. And is the absolute value of 1 equal to 1? It is. This one works out. Let's try the negative square root of 2. So I have negative square root of 2 squared minus 1. What is the negative square root of 2 squared? 2. Yeah, it's still positive, right? Because I'm squaring. So it's 2. And 2 minus 1 is 1. And the absolute value of 1 is 1. So we're good to go. This one checked out as well. And then the third one, 0 squared minus 1. So what is 0 squared? 0. Minus 1 gives me negative 1. And what's the absolute value of negative 1? It's 1. So this one also checks out. So all 3 of these solutions actually did work. I have 3 solutions for this problem. Any questions on that one? Okay, so last class period, I ended the class period with a radical example where there was one radical and the other stuff was not underneath the radicals, right? And then when we started the class session today, I had 2 radicals. Agreed? So now I've done an absolute value where there's 1 absolute value. So what do you think is coming next? 2. That's right. So let's take a look. So on this one, I have 2 absolute values. 2x minus 3 absolute value equals 2x plus 7 absolute value. Okay, so if I have these 2 quantities inside of the absolute values, one possibility is they're exactly alike already, right? Let's say that the left-hand side's positive and the right-hand side's positive. If they're both positive, we just lift the absolute values and we're good to go, right? Yeah. Let's say they're both negative. If the left-hand side's negative, well, then I have to change the signs. All the signs change, right? And if the right-hand side's negative, well, all the signs change, right? So if I change all the signs on the left and I change all the signs on the right, then I have, again, the quantities equal to the same thing that they originally were, because I've multiplied, in essence, everything by a negative 1. So one possibility, that's the first possibility, is that the two quantities are either both positive, and I just lift the absolute values, or they're both negative, and I multiply everything by a negative 1, which makes them equivalent. So one option is that 2x minus 3 is equal to 2x plus 7. Okay? And the other sort of inherent option in this is that it's 2x plus 3, like this, is equal to negative 2x plus 7. But if I have this, I could just multiply everything by negative 1, and it would be the first one. Do you guys see that? So as long as the signs are both positive, left hand and right hand, or both negative, left hand and right hand, I get the same equation to solve. It's nothing new. So this one really does not present a new solution. It's the same solution, if there's one at all. The second option is that the signs don't match, right? The left-hand side's positive and the right-hand side's negative. Or the left-hand side's negative and the right-hand side's positive. So if that were the case, then one side gets multiplied by a negative 1 and then the other side does not. And again, it doesn't really matter which side I multiply, I'll get the same solution. So take a look. If I say, hey, look, the left-hand side's positive, so I can just lift the absolute values. Sorry, I'm changing my signs as I keep going. I don't know if you guys can tell when I'm doing this, but I'm constantly zooming in and zooming out, and so I lose signs very easily because of that. That's what happens. So when you see me losing signs, please let me know. This one is messed up. It's a negative. Okay. So if the left-hand side's a positive value, right, like let's say that x is 7. Well, 2 times 7 minus 3 is positive. I just lift the absolute values. I don't need them. And then the left-hand side we say is negative. Well, if the left-hand side's negative, I have to multiply by a negative 1. So I have negative 2x plus 7. Or maybe the right-hand side's the negative 1. And the left-hand side's the positive 1. But again, that's the same equation. Because if I multiplied everything over here by a negative, it would become this, right? Negative on the left and the right. So I don't actually have two things to solve. And if you want to, go for it, but you're just going to do twice as much work because you're going to get the same solution here and here on the second two equations, and you get the same solution on the first two that I wrote down as well. So it's enough to solve one of each of them. So let's look at the first one. If I try to solve 2x minus 3 equals 2x plus 7, what would you do first? Subtract something, right? What do you want to subtract or add? Somebody give me a suggestion. Add 3. Okay. Okay, now what? What else is there to do?
Subtract 2.
Subtract 2x, right?
Yeah.
And whether we do that at the beginning or whether we do that at the end, like we did at the end here, what happens? They cancel out on both sides, right? I don't have any more x's. So I end up with something like this, 0 equals 10. Or if we had subtracted the 2 x's at the beginning, I would have had negative 3 equals 7. Does 0 equal 10? No. And negative 3 doesn't equal 7 either. This isn't true, right? So from this perspective, there is no solution. So there's no solution to this part of the problem. Now, there might be to the second part, but there's no solution by setting them both equal to each other without their absolute values. It doesn't work. I don't get a solution out of it. I could have, but I didn't on this one. So looking at the second one, the first thing I'm going to do is I'm going to distribute my negative through. Okay? So I've got 2x minus 3 equals negative 2x plus 7, or minus 7, sorry. So what would you like to shift or move first? Somebody give me a suggestion.
It's,
Add 3. I heard somebody say add 3. Okay, so I have 2x equals negative 2x, and this one is actually now my minus 4. Then what? Add 2x. And you don't have to do them in the order we just did. If you'd added 2x first and subtracted 3 second, that's fine. 2x plus 2x is 4x. This time they don't eliminate. So 4x is equal to negative 4. And what would I do as my last step? Yeah, I divide by 4. So this gives me, as a potential solution, x is equal to negative 1. Okay? But I still have to check it, because I eliminated absolute values as I was working, and I might have introduced something into the problem that didn't actually work. And the only way to check that is to actually check the solution that I've potentially gained. So I have the absolute value of 2 times, is it negative 1? Yeah, negative 1 minus 3. And it's supposed to equal, or we're trying to see if it equals, 2 times negative 1 plus 7. Okay, so let's try to do each side. 2 times negative 1 is negative 2, and negative 2 minus 3 is negative 5. Absolute value of negative 5 is 5. So this is absolute value negative 5, and then we got 5. Okay, let's do the same thing on the other side. 2 times negative 1 is negative 2. Negative 2 plus 7 is 5. So I have an absolute value of 5. So notice, they really do, in fact, have the same value, opposite signs inside of the absolute values. And then, of course, when I take the absolute values, they match. So they are doing exactly what I predicted would happen if that gave me a solution. So the only solution we have, this is actually our solution then, is x equals negative 1. So those are some absolute value type equations. There's one more type of miscellaneous equation in this section. And this type is what they call actually a quadratic type equation. So what you see happen in these is that the exponents aren't really x squared, x, and constant. But they almost look like it. Right, I don't have x squared, x, and constant. I have x to the 4th and x squared and a constant. So when I solve these, I use very much of the, that's terrible grammar. I use a lot of the same techniques as I do with quadratics. So on this one, we're going to factor it just like it was an x squared, an x, and a constant. But the difference is that I need 2 values that multiply together to give me x to the 4th. What 2 values multiply to give me x to the 4th? Yeah. Some of you are like saying it underneath your breath. You don't want to talk to me out loud. That's okay. X squared and x squared. That'll do it, right? That'll give me x to the 4th. Not only that, but when I do the inner terms and the outer terms, it'll give me the x squared in the middle. So that is the right one. But then the rest of the factoring, again, looks just like it did when we did quadratics. I need 2 numbers that multiply to 10, and they add to negative 7. 2 and 5. Positive or negative? Negatives. So I get a negative 7, right? Awesome. And again, just like I would do if I were doing quadratics, I'm going to set each piece equal to 0. X squared minus 2 equals 0. X squared minus 5 equals 0. And I'm going to solve them. So I'm going to add the 2 to the right. I'm going to add the 5 to the right. And then what do I do in order to solve this? Square root, yeah. And when I put square roots on problems, what do I have to remember? A plus or minus. So this is x is equal to plus or minus the square root of 2. And x is equal to plus or minus the square root of 5. Okay. I'm going to put this in here. Again, you should check these. These are far less likely to fall apart than the previous problems that had radicals and absolute values in them. These 4 all check out. So I'm not going to check these with you, but understand that it's a good idea to check, even if you just checked with your calculator to make sure something worked and didn't actually write it down for a check step, just to be aware, okay? So we should check these. They do all 4 work, so I end up with 4 solutions. I have one more problem. Yes, Wesley?
Whenever it's x to the 4th, doesn't that always mean you're going to have 4 solutions?
Yes and no. It means I'm going to have 4 solutions, but some of them could duplicate. Like I could end up with an x equals to 2 twice. So they aren't necessarily 4 different solutions, but yes, there are 4 solutions. Yeah. Okay, I have one more quadratic type 1 before we finish this section and move on to 1-7. So let me just say right now, it looks way worse than it is. Promise. Okay, so jot that one down. There's a lot going on visually. Okay, now think with me for a moment. I promise I'll erase my scribbles. If what was scribbled away simply said x, then this would be a quadratic equation, right? I'd have x squared minus 2x and minus 3. Do you agree? So don't get distracted by what's being squared or what's in those parentheses. Right now I'm going to leave those scribbles on here, and what I want us to do is I want us to actually figure out, I'm going to use brackets just because I'm going to have some parentheses later. Figure out what happens in order to get the -2 here. So this needs to be a -2 in the middle, and it needs to be a -3 on the end. So what numbers go at the end of these parentheses or these brackets? I have to multiply to 3 and add to 2, or subtract to 2. 3 and 1. Okay, is one of them positive or one of them negative, or like what do we have? Which one's positive?
The 1.
The 1 is positive, yes, and the 3 is negative. So those multiply to -3, and they add to -2. Is everybody good with that? Okay, and then all the stuff I scribbled out in yellow, it's going to go right here. I am going to replace it in my next step. Okay, but that piece just gets plugged in that spot. That's all that happens. So what I really have now is I don't even remember what it was because I covered it up. Let me take it off. U squared plus 2u and then plus 1. And I have u squared plus 2u and minus 3. Okay, so the scribbled piece that I covered up is now put back in where it actually belongs. The nice thing is that what I end up with, again, are quadratics. And I actually can solve those too. Before I do, or you know what, let me do it this way. Just like on the last problem, we can set each piece equal to 0. So I have u squared plus 2u plus 3 equals 0. And I have u squared plus 2u minus 3 equals 0. But how do we solve those? They're quadratics, right? So if possible, we would like to factor, right? Now, this one, the second one, it looks almost like what I started with. Joe?
I'm sorry, how'd you get plus 3?
Because I keep shifting in and out. How about a 1? Is that better?
Oh, okay.
Thank you. Yeah, there's a 3 over here, so I got hung up on my 3. Thank you. All right, so the second piece, the u squared plus 2u minus 3, is almost the same as what I started with. It has a different sign in the middle on the 2, but everything else is actually the same. So that piece actually very nicely will factor with the same 3 and 1 I had before, but the sign is positive on 3 and negative on 1. And I really do just have the u in each of the places now instead of the yellow mess, right? On my other one, how will this one factor? How does u squared plus 2u plus 1 factor? I'll start you out. There's a u at the front. Yeah, and then it's 1 and 1. So we're going to do it again. We're going to set each part equal to 0. So I have u plus 1 equals 0. U plus 1 equals 0. And then over here I have u minus 1 equals 0. And I have u plus 3 equals 0. So Wesley, this is actually an example of one where these are going to give me the same solution. So yes, I have 4 solutions, but 2 of them happen to match. So this is u is equal to negative 1. Over here, u is equal to positive 1. And what's this last one? Yeah, negative 3. And again, I will leave it as an exercise to the reader. That's what you see in actual high-level math things. They don't solve a lot of stuff. They just say left as an exercise to the reader. It's a cheap way of not having to do it, but you should check them. They do all work on these, okay? All 3 of these solutions, there's 4, but 2 of them match. They actually do work in the original equation, okay? Any questions on that? Okay, so I know that in the past sometimes people will ask me, well, could I just square this out and keep going from there? And the answer is you could. The reason that's not very friendly is because then you're going to have a u to the 4th power, you're going to have a u cubed, you're going to have a u squared, you're going to have a u, and you're going to have a constant, and you're not going to know how to factor that because we haven't done quartics, powers of 4 in factoring. So no, it's not a good idea to square that out and actually clean that up, so to speak, before you actually start factoring. The goal is eventually to factor. We want to start factoring as soon as we can.